So stationary points are those points where the derivative is 0. Now there are three kinds of stationary points. The local maximum is a stationary point. Stationary point means the derivative is 0. So that's the meaning of stationary point. There are three kinds: local max, local minimum. Here also the slope of the tangent is 0. Local minimum. And you have your horizontal point of inflection. It can be like this. This is your horizontal point of inflection. Now what's the point of inflection? Point of inflection is where the curvature is the curvature changes. So it's concave down, and after the point of inflection it is concave up. So what is common between all of them? Common between all of them is first order derivative is 0. First order derivative is 0. That's the first condition. Now here, what is this? How will you come to know it's a local maximum? You can look at the second order derivative test. So you put the value in the second order derivative. You put the value in the, you know how to find the second order derivative, no? You put the value in the second order derivative. Suppose the point is A, correct? So suppose the local maximum is point x is equal to A. This will be negative. Negative means it's concave down. So basically what you need to remember is, to get a local maximum, look, I'll give you 10 to copy. To get a local maximum, two conditions have to be required. Your first order derivative has to be 0 and your second order derivative has to be negative at that point. Means it should be concave down. Second order derivative negative means it's concave down. For the local minimum, first condition is the first order derivative is 0, and the second condition is, suppose at this point x is equal to b, let's call it x is equal to b, your second order derivative at that point will be greater than 0. Greater than 0 means what? It's concave up. So again, two conditions for this. What are the two conditions for local minimum? Yes. The first order derivative 0 and your second order derivative is positive, means it's concave up. If only if it's concave up, you will get a minimum. Point of inflection, your first order derivative is 0, your second order derivative is also 0, and there's a sign change for the second order derivative. Second order derivative, there's a sign change. So in the above diagram, it's concave down and then concave up. So there are three conditions for horizontal point of inflection. First, your first order derivative is 0. Second condition, your second order derivative is 0. And third condition, there should be a sign change, means there's a concave down. This is minus, means it's concave down. And after the point of inflection, this is concave up. So you must learn this up. Now take it down. Now here this question shows that for each of the following functions, find and classify any stationary points. Sketch the function showing all important features. So what you need to do is, whenever you are finding any stationary point, what's your first step? Find the derivative. So y is equal to x cube plus 1. So your, yes, so your dy by dx is equal to 3x squared. First pay attention. Then what do? You take your dy by dx is equal to 0. Remember, there is a condition for stationary point. So 3x squared is equal to 0. So what is the value of x you are getting? 0. Now you have to classify it. Now there is a stationary point. Now to classify it, you put this value in the second order derivative. So you find your second order derivative. So you take this answer and take the derivative again. What is it?
So it will be 6x.
6x. You put the answer that you got over here.
So 0.
0. Now, so that means can be a point of inflection because If it's 0, but you know, point of inflection has 3 conditions. So what do you have to do for point of inflection? You have to look at the sign change. So you draw your second order derivative ka number line. We got this answer as 0. This is your second order derivative answer line. Take a number less than 0. What is that?
So -1.
-1.
So 6
-6. So negative. Take more than 0.
So 1.
Positive. So it is a point of inflection. So there's a point of inflection at which point?
At 0.
There's a stationary point of inflection at x is equal to 0. How do you sketch this graph?
So there is no attachment with this.
Yeah, so that your this will be 1. This is 1, no? Because your x cube ka graph is translated 1 unit up.
Yeah.
So this is your point of inflection at 0. This should be exactly here. Minus dashes come slightly this. Should come exactly here. Correct? This is the x-axis, this is the y-axis, and that's how your graph will be. So what do you need to do? Your first few steps are correct. So you find the first, I'm doing part B. You first find the first order derivative. 3x square minus 3. Correct? Make it equal to 0. Solve for x. So 3x square is equal to 3. X square is equal to 1. X is equal to plus or minus 1. Then you take the second order derivative. What is the second order derivative would be? 6x. Now put plus 1 in this. So 6 plus 1 is 6. Positive. If it's positive, it's a local minimum. Correct? Local minimum at x is equal to 1. Then you put this in the put minus 1 in the second order. Then these are two answers. These are two answers. So first you put plus 1, minus 1. You put them separately. So this will be minus 6 less than 0. Means it's a local maximum at x is equal to minus 1. So that means you have to draw only one graph now. You don't have to draw two separate graphs. You're drawing one graph only. So you have your x-axis, you have your y-axis, you have your minus 1, plus 1, and you can also come to know your y-intercept. To find out the y-intercept, you put x as 0.
Yes.
So if you put x as 0, so your y is equal to 2.
Yeah.
So you'll get your y-intercept basically by orally just looking at the graph. So y-intercept is at 2 basically. Now at minus 1, there's a local max. At 1, there's a local min. So that means your graph would be like this.
Oh.
Cutting at 2. Then there's a local maximum at minus 1. They haven't asked you in this question. If they ask you find the coordinates of the local maximum and minimum, how do you find the coordinates of the local maximum?
You substitute 1 and then minus 1.
Where?
In the original.
In the original function. If they ask you that, they haven't asked you this. Look, what will you first do? Tell me. First, find a first order derivative. Dy by dx, if your teacher likes to call it. 4x cube minus, how much is it? 4x. Correct? Make it equal to 0. So if you remove 4x common, you will be left with what? X square minus 1. So x is equal to 0. Or x is equal to minus 1 or x is equal to plus 1. Correct? Okay, that's good if you have done that. Then you find a second order derivative. What's the second order derivative? So 4x cubes are 4 3s are 12x squared.
Square minus 4.
Minus 4. Now what do you do? Now there are three answers, no? So you put each of them down.
Yeah.
You put each of them. So suppose you take it, I don't know when a teacher would approve of calling it f dash x 0. So 12 into 0 square minus 4. So minus 4, which is negative. If it's negative, then what is it? It's concave down. Concave down means what? It's local maximum.
Yeah.
Means the local maximum at x is equal to 0.
Yeah.
Then if you have f double dash of minus 1. So 12 into minus 1 square minus 4.
That's it.
That's 8. Correct? If it's 8, then what is it?
Positive.
Positive. Positive means what?
It's like that.
Like that means what?
Smile.
Smile means local minimum. When it's positive, so you smile. Correct. So it's local minimum. At which point? At x is equal to minus 1. Correct. And then you take this 1, which is also 8, which is positive. So local min at x is equal to 1.
So you go like that.
What's the y-intercept?
So y-intercept is 0.
Because when you put your x as 0, y-intercept is 0. It's passing through the origin. So that means if you're trying to draw the graph, you're trying to draw the graph, this is 0, this is minus 1, this is 1. It's passing through the origin. Okay, it's passing through the origin, and at origin what do you have? Local minimum.
Yeah.
You have local minimum at the origin. Correct? At x is equal to minus 1, what do you have? Local maximum, sorry. At the origin you're having local maximum. At minus 1 you're having what? Local minimum. So obviously it will be here. And at 1 you're having local minimum. So that means your graph would be like this, like this, like this, and like this. Local minimum, local maximum, local minimum. So that's how you to draw the graph. That's your function. You're following that? We are not finding the coordinates. If they ask you the coordinates, you can plot the coordinates as well. So did you follow? So what are the steps for finding and classifying the stationary points? Very simple. Take the first order derivative, make it equal to 0. You may get one answer, you may get two answers, or you may get three answers. Each of those answers you have to put them in the second order derivative to decide. If it's negative, then it's what? Sad face. It's concave down. Concave down means a local maximum. If it's positive, it's a local minimum. So this is how you can plot.